Hello students, and welcome to our first video lesson. I hope you are all doing well. Today's video we're starting new material. You want to have handy your paper plate, your textbook, a blue pencil or pen, and your regular pencil or writing utensil. Today's plan is to look at a point not on a unit circle using our paper plate. And then we're going to do exercises out of the textbook, starting with page 358, exercise 3 and 4, then page 364, exercise 4, 363, exercise 2, and 365, exercise 6. So we'll be jumping around the textbook a little bit. All right, so we're on this side of the paper plate where you have your red unit circle drawn. And just remember what's so important about if there's a point on the unit circle, right? Like we have here our x, y coordinates. This point here is on the unit circle. Then the x coordinate is equal to the cosine of the angle, and the y coordinate is equal to the sine of the angle. And you should also probably have this box. We know that unit circle is x squared plus y squared equals 1. Remember, unit circle has a radius of 1. And then we replaced x with its equivalent, cosine theta. So we have cosine theta squared plus sine theta squared equals 1. This is what's going to be known as the Pythagorean identity. This is something you have to memorize, and we see used quite often on the Regents exam. But today's lesson, we're looking at a point not on the unit circle. So what you want to do is you want to take this embossed circle and kind of trace it using your blue pencil or blue pen if you don't have a blue pencil. And again, if you need to, you can always pause the video. So here's a circle which is not the unit circle. We are going to place a point in quadrant 2. So I'm going to put a point up here. Its x coordinate would actually be negative. So I'm going to label this as negative x, positive y. And I think I'm just going to switch to a blue pen because it may show up better. So we have our point negative x, positive y. And again, this is not on the unit circle. So let me write down here. Not on unit circle. Right, only our red was our unit circle on this paper plate diagram. And like we did with our red triangle, right triangle for the unit circle, we're going to do the same with this point. Right? We're going to drop a perpendicular down to the x-axis. Actually, what I should have done first, I'm sorry, is I should have drawn our actual terminal ray of our angle. Right? So it's like this. We have this angle here, and this is its terminal ray. And we're using its terminal ray as the hypotenuse of our right triangle. This is going to be what would be considered our reference angle, theta. Right? Remember, our reference angles are always formed with the terminal ray and a portion of the x-axis, in this case the negative portion of the x-axis. So here we have our right triangle. In relation to our angle theta, this side here is opposite the angle. And it is actually the length of whatever our y coordinate is. So label this y, right? If this was, let's say, a height of 10, then this is 10. And our base of our right triangle would have a length of whatever our x coordinate is. So here we have our right triangle. We have legs x, y, and we have our hypotenuse, which is equal to the radius of our circle. So if we want our sine, cosine, and tangent functions of theta, well, sine we know is opposite over hypotenuse. So this would be y over r. Cosine of theta, cosine is adjacent over hypotenuse. Adjacent over hypotenuse, x over r. And tangent is opposite over adjacent, y over x. Now, how can we find r? Pythagorean theorem. X squared plus y squared equals r squared. So r squared equals x squared plus y squared. We take the square root of both sides, and we have that r equals the square root of x squared plus y squared. Now again, this is for a point not on the unit circle. Next, we want to talk about our quadrants. All right. In quadrant 1 here, our x and y coordinates are both positive. So sine, cosine, and tangent of the angle are positive. So we say all positive in quadrant 1. They're all positive. In quadrant 2, well, our x's are negative, so meaning our cosine values are negative. Our y's are positive, so our sine values are positive. And in fact, only sine is positive. So in quadrant 1, they are all positive. In quadrant 2, only sine is positive. In quadrant 3, well, both the x and y coordinates are negative. So that would make tangent positive, right? Because you'd have negative over negative, which would make it a positive. So only tangent is positive in quadrant 3. And in quadrant 4, our x coordinates are positive, our y coordinates are negative, meaning cosine is positive in quadrant 4. There's only one more thing where we will add to the paper plate, and that will be in tomorrow's lesson. So now we are going to the textbook, page 358, and we're doing exercises 3 and 4. All right, I'm just going to put paper plate up above, and now this is page 358. It's important to be able to determine the sign, positive or negative, of each of the 3 basic trig functions for an angle whose terminal ray lies in a given quadrant. For each quadrant, determine if the sine, cosine, and tangent of all angles whose terminal ray falls in the quadrant is positive or negative. And going back to the paper plate, we said that they were all positive in quadrant 1. Only sine was positive in quadrant 2. In quadrant 3, tangent is the only one that's positive. And in quadrant 4, cosine was the only one that's positive. So we have this acronym, All Students Take Chemistry. ASTC. All Students Take Chemistry. Our quadrants, we start in the upper right and go counterclockwise. So A is for all. All 3 trig functions, sine, cosine, and tangent, are positive in quadrant 1. S is for sine, all students. Sine is positive in quadrant 2. T is for tangents, positive in quadrant 3. And C is for cosine, is positive in quadrant 4. So filling in the table here, in quadrant 1, they are all positive. Sine, cosine, and tangent are positive. In quadrant 2, just sine is positive. Cosine and tangent are negative. Quadrant 3, just tangent is positive. Sine and cosine are negative. And in quadrant 4, cosine is positive. Sine and tangent are negative. So you have to know, this is something you have to memorize, your signs and quadrants. All students take chemistry, meaning 1, 2, 3, 4, A, S, T, C. All students take chemistry. Exercise 4. Name the quadrant in which the terminal side of theta lies if the sine of theta is less than 0. Well, meaning, okay, so the sine of theta is less than 0, meaning they're all negative, right? If it's less than 0, then they're negative values. The cosine of theta is greater than 0. If the cosine of theta is greater than 0, those are all positive values. So we want to find the quadrant in which sine is negative and cosine's positive. Well, first I would go with positive. Cosine is positive in quadrants 1 and 4, right? Cosine's positive in 1 and 4. Out of quadrant 1 and 4, in which one is sine negative? Well, sine's negative in quadrant 4. Number 2, the sine of theta is greater than 0 meaning it's positive, and the tangent of theta is less than 0 being negative. All right, sine's positive in 1 and 2. Out of these 2, in which one of these quadrants is tangent negative? Tangent's positive in quadrant 1. It's quadrant 2 that tangent's negative. Sine of theta is greater than 0. Greater than 0, that means it's positive. Cosine is greater than 0. All right, sine and cosine are both positive in quadrant 1. Cosine of theta is less than 0, meaning it's negative. Tangent theta is greater than 0. Tangent's positive. Okay, tangent's positive in 1 and 3. And in which one is cosine negative? Oh, in 3. Cosine's positive in 1. Number 5, tangent theta is less than 0, meaning negative. Cosine theta is greater than 0, positive. And certainly you're more than welcome to stop the video and do 5 and 6 on your own. Try them on your own. Cosine's positive in quadrant 4, and tangent is negative in that quadrant as well. Cosine was positive in 4 and 1. Sine of theta is less than 0, negative, and cosine of theta is less than 0. So sine and cosine are both negative in the quadrant that tangent's positive, quadrant 3. Now we're going to page 364, exercise 4. We already did exercise 3 on this page. Now exercise, just important to remember, right? And if you have a highlighter, whenever you're on the unit circle, the sine of theta is equal to the y-coordinate, cosine of theta is equal to the x-coordinate. That was a previous lesson. But on the second half of page 364, this is for any point P in the coordinate plane but not on the unit circle. So that's using what we learned on the paper plate. Right? When we're not on the unit circle, okay, the sine of your angle is going to equal the y-coordinate over the radius. The cosine's the x-coordinate over the radius, and the tangent is y over x. And how do we find the radius? Well, we can use Pythagorean theorem, where the radius is equal to the square root of x squared plus y squared. Okay, so you can do 2 things here, all right? You can do these first 4 steps, which is to plot the point, draw a segment connecting the origin to the point, which that's the terminal side of your angle theta, mark angle theta, draw a right triangle. Remember to always use the x-axis for the base of the right triangle, never the y-axis, and use Pythagorean theorem to find the hypotenuse. Then use SOHCAHTOA, right? Or you can memorize. You can memorize that sine theta equals y over r. Again, that's what we put on the paper plate. Cosine theta equals x over r, and r is simply the square root of x squared plus y squared. So we have the point P, negative 5, 12. Well, negative 5, positive 12. So I mark a point up there. There it is. There's our point P. Connect the point to the origin. Right? Make this so that this is now the hypotenuse of a right triangle. So we drop a perpendicular down, label our angle theta. The y-coordinate, 12, is the length of the side opposite, and 5 is the x-coordinate. That's our base of our right triangle, or in relation to angle theta, the length of the side adjacent. Well, what is r? This, if you know the Pythagorean triple, 5, 12, 13, you can just put 13. Otherwise, you're using Pythagorean theorem, 5 squared plus 12 squared equals, in this case, you can say c squared or r squared. So r equals the square root, 25 plus 144, which is 169. So r is 13. So again, you can memorize the y over r, or you can draw the right triangle and now say hypotenuse, opposite over hypotenuse. And we're in quadrant 2, where sine is positive. So Positive 12/13 is our answer for sine theta. Cosine theta is adjacent over hypotenuse, or you simply use x over r. 5/13. And if we use the true x, it was a negative 5, right? And that's because we are in quadrant 2 where cosine is negative. So if we write just the 5/13, we also have to put the negative sign in front of it. So try number 2. Pause the video if you like and try example 2. We have the point 1, -7. So that puts us in quadrant 4. So I connect the origin to the point. In this case, you're drawing a perpendicular to the x-axis. Again, you always go to the x-axis, never the y-axis. Draw in your angle theta. Adjacent is 1, opposite is 7, and now the hypotenuse, Pythagorean theorem, 1 squared plus 7 squared equals c squared or r squared. They're one and the same in this case. So that's 50, square root of 50. If I wanted to simplify that, 25 times 2 is what we're thinking, and the square root of 25 is 5. 5 square root of 2 equals r. So the sine of theta is going to be opposite over hypotenuse, 7/5 square root of 2. We are in quadrant 4, where sine is negative, so we need to put a negative in front of our fraction. And cosine is adjacent over hypotenuse, 1/5 square root of 2. Now we're going back one page, to page 363, and doing exercise number 2. So this is page 363. And before we do exercise 2 on this page, let's look up above in the box. It says, since each point on the unit circle must satisfy the equation x squared plus y squared equals 1, we can now state what is known as the Pythagorean identity. All right, so this is true for any angle. It's an identity, and an identity is true for any value of your variable. In this case, for any angle, this is true. So sometimes you're going to be given just maybe the sine or the cosine of an angle, and you want to find, well, if you're given the sine, what's the cosine of that angle? Well, you can use this. Cosine theta squared plus sine theta squared equals 1. So in exercise number 2, it says an angle theta has a terminal ray that falls in the first quadrant, and cosine theta is equal to 1/3. Determine the value of sine theta in simplest form. Well, we're first going to use the identity. So following the same as what would have been done above if we were to do exercise 1, we want to use the Pythagorean identity, which is cosine theta squared plus sine theta squared equals 1. Okay, so the cosine of theta is equal to 1/3. So we put 1/3 in for cosine theta. Well, 1/3 squared is 1/9. We want to get sine theta by itself, so we subtract 1/9 from 1. And we have sine theta squared equals 9/9 minus 1/9 is 8/9. And now, square root both sides. So the sine of theta equals, we composed that square root, or I did, plus or minus the square root of 8/9. Now, let's simplify the square root of 8. We're thinking 4 times 2, and the square root of 4 is 2. So 2 square root of 2, and the square root of 9 is 3. What quadrant are we in? We are in the first quadrant, all right? So our sine of theta is equal to positive 2 square root of 2 over 3. The other method is to draw a right triangle in the given quadrant. So I'm following 2 from above here, right? Draw a right triangle in the given quadrant. So we're in quadrant 1. So I just draw a right triangle in quadrant 1. Cosine is adjacent over hypotenuse. So adjacent would be 1, hypotenuse 3. And then we could just use Pythagorean theorem to find the length of the side opposite. So I would say 1 squared plus b squared equals 3 squared, right? A squared plus b squared equals c squared. That's 9. That's 1. 1 plus b squared equals 9. B squared equals 8. So b equals, we're talking about length here, so I'm just going to leave it as 2 square root of 8, or sorry, 2 square root of 2. 2 square root of 2. Right, square root each side. We're in quadrant 1 where sine is positive. So if this is 2 square root of 2, then our sine of theta is equal to opposite over hypotenuse. So this, what's considered the Pythagorean identity, can be used for any angle. And our last exercise, I believe, is page 365, number 6. This is page 365. The point E, -7, -24, lies on the circle. It doesn't say unit circle, it says a circle, whose equation is x squared plus y squared equals 625. If an angle is drawn in standard position and its terminal ray passes through E, what is the value of the sine of this angle? Okay, so we want the sine of this angle. And this point is not on the unit circle. If it was on the unit circle, we could just say then the sine value is whatever the y-coordinate is. But this is not on the unit circle. It tells us the circle that it lies on. So this 625 represents the radius squared. So r squared equals 625. What is the square root of 625? All right, it's 25. So now we can use, if we're looking for sine, right, we can take just y over r. So the sine of theta is -24/25. That's just one way, right? Or we can take the point, plot the point, we're in quadrant 3. Draw our right triangle in quadrant 3. 7, 24, use Pythagorean theorem to figure out to find our hypotenuse of 25. Oh, I'm sorry, that didn't show up at all. All right. And then sine is opposite over hypotenuse, but we are in quadrant 3, where sine is negative. Or one last way. No, I'm sorry, we're done. Okay, so now you have the homework assignment, which is page 362, numbers 7 and 8, and page 366 to 367, 1 through 8. And also just check, there may be a few Delta Math questions. Just check what is assigned in teams. Thank you very much, and I hope you have a great day.